Now let's look at how automotive technicians apply these math skills in the field. Oftentimes, technicians will add whole and decimal numbers when calculating voltage. Voltage is the electrical potential as measured between the positive pole and the negative pole of a power source. Voltage drop is the measurement of how the energy is reduced at each electrical load in the circuit. This all relates to the properties of voltage and Kirchhoff's voltage law. According to Kirchhoff's voltage law, to calculate source voltage, you can add all the voltage drops together. We'll say voltage drop 1 plus voltage drop 2 plus voltage drop N. N doesn't represent any particular number. It just means that we can add as many voltage drops into the equation as we need to represent the circuit. Let's look at an example. An electrical circuit has 3 electrical loads within the series circuit. These electrical loads each have a voltage drop of exactly 3 volts. Calculate the source voltage. Since we know our formula for source voltage is equal to all the voltage drops added together, we can set up this problem similarly. In this instance, it'll look like this. Source voltage equals 3 volts plus 3 volts plus 3 volts. This represents the 3 electrical loads that each have a voltage drop of 3 volts. After we add this together, we can get the total source voltage, which is 9 volts. Our second example asks us to calculate a similar total, but in a slightly different way. An electrical circuit has a power source of 20 volts. Within the series circuit, there are 2 electrical loads. The first electrical load measures 12 volts for the voltage drop. Calculate the amount of voltage drop at the second load. Although this problem is similar to our first example, it'll be set up a little differently. On one side of the equal sign, we'll put our source voltage, which we were given in the problem. That's 20 volts. On the other side, we'll put our first electrical load, which we know measures 12 volts. To calculate the second load, we'll put an X and solve. Remember, just like in the review problems before, you want to make sure to get X on its own by subtracting 12 volts from both sides. That leaves us with the answer X equals 8 volts. Now that we've completed a few practice problems together, you'll have the opportunity to apply what you've learned to practice a few on your own. Please make sure to complete all 8 problems before logging out of this module.